Hey guys, in this video we're going to be talking about factoring, kind of, seeing two special cases that include GCF, which is the greatest common factor, and the difference of two squares. The difference of two squares. Okay, so what is GCF? So GCF stands for greatest common factor. So greatest common factor. And basically what this means is that when you have a set of numbers, so like 4, 8, 16, you're looking for the greatest common multiple, so or factor. So 4 is divisible by 4 evenly. It can also be divisible by 4 here and here in 16 as well. So, but you can also divide these numbers evenly by the number 2. So I could say divided by 2, divided by 2, divided by 2. So 2 and 4 are factors or multiples of these three numbers. But 4 is the greatest, and we're looking for the greatest, so it would be 4. 4 is the GCF of these three numbers. Okay. So now that we know what GCF is, let's look at a few examples with expressions. So let's say we have 18 plus 8m cubed. So what we're going to do is look at the coefficients first. We have 18 here and 8. Those are our two coefficients. And our greatest common factor of these two numbers is 2, because 2 is the only number that divides evenly with these two numbers. And then you can have and then you kind of draw a line and say, what is 18 divided by 2? That's 9. Bring the plus down. 8 divided by 2 is 4. And then there's nothing for m, so m cubed. There. So that is your answer for the first problem. So now let's say we have something like this. So 9p to the 6th minus 18p to the 5th plus 36p cubed. So what you're going to do is take your coefficients first. So 9, 18, 36. So our greatest common factor here is 9, because 9 divides evenly among all these three numbers, and it's the greatest common factor. So it's the GCF. And then you're going to look at your variables next. So you're going to look at the exponents. And you're going to take the smallest one, your smallest value for your exponent, and that's 3. So P3, and you're going to write that down. Next, you're just going to draw your line and open your parentheses. So 9 divided by 9 is 1, so you don't have to write that down. And then 6 minus 3, because you're dividing, so you would subtract the exponent. So 6 minus 3 is 3. Negative 18 divided by 9 is negative 2. 5 minus 3 is 2. And then 36 divided by 9 is 4. And then 3 minus 3 is 0. But p to the power 0 just means 1. So you don't have to write that down. Okay, so this would be your final answer for this question or expression. Next, we're going to be looking at factor by grouping. That's our next one, so factor by grouping. And then we'll move back up to difference of two squares. So factor by grouping. So let's look at an example here. So factor by grouping basically means you're splitting the equation in kind of like two sections. So let's say we have x squared. So I'll move this down. So we have x squared plus 9x plus 20. What you're going to do is split the middle in two sections. So 9 squared plus, and you need two numbers that add up to 9. So this number and this number have to equal 9. And these two numbers should also multiply out to a and c. So 20 and 1. So let's write this down. So A, C, B. So you can kind of divide your expression into three sections. So A, B, and C. So two numbers have to be multiples of A times C, or A times C value is 20 times 1 is 20, right? And our b value is 9. So what you're going to do is find two numbers that multiply up to get 20 and two numbers that add up to get 9. And those numbers are 4 and 5. So 4 times 5 is 20 and 4 plus 5 is 9. So you're going to write 4x, kind of make that line, and then you're going to write 5x, or you can write plus 5x plus 20. And kind of, separate that with a squiggly line. I prefer a squiggly line so you don't get confused if you put a line like that, and you might get confused saying that that's a 1. So use a squiggly line. But it doesn't matter if I put the 5 here or if I put the 5 here or here. It doesn't matter, and we'll take a look at that in a second. But we're going to put the 4 here and 5 here for now. So once I do this, I'm going to use the GCF factoring method here. So our greatest common, we're going to look at our variables first. So our coefficients, sorry. We're going to look at our coefficients first, and there's like a 1 here. So our greatest common factor between these two numbers is 1. But we're not going to write that down. Or let's just write that down for purposes. And next we're going to look at our variables. So this and this. We're going to look at our smallest value. So our smallest value here is 1. So x raised to the power of 1. And then you can just open your parentheses and draw that division symbol. So 1 divided by 1 is 1. 2 minus 1 is 1. And then plus 4. 1 minus 1 is 0. And then x to the power is 0. So that's just 1. So you don't have to write the multiplication ones because anything multiplied by a number is the same thing. So here we're going to do the same. Look at our coefficients first, which is 5 and 20. So the greatest common factor is 5. Draw your division symbol. 5 divided by 5 is 1. X comes down plus 4. So note that both the insides for this side and this side are the exact same thing. They have to be the exact same thing or you've done something wrong. So make sure the insides have to be the same. So insides, same. So now that you've done that, you can bring one of them down into your final answer. So x plus 4. And then all you're going to do is open another parentheses, put your outside this side and this side, so plus 5. And this is your final answer. That's factor by grouping. Finally, let's look at another example. So let's say we had 3. So actually, yeah, let's do this. So we have 3x squared minus 10x minus 8. We first want to look if there's any greatest common factors here. We have none. So all you're going to do is write 3x times negative 8 is a times c. So a, b, c, label those first. And then a times c, so 3 times negative 8. Don't forget the negative, it's very important. 3 times negative 8 is, so we're going to do 3 times negative 8, and that's negative 24. And then we're going to do here, our b value equals our b value, so that would be negative 10. So we're trying to find two numbers that multiply out to get negative 24 and two values that add up to 10. And those values are going to be 2 and negative 12. So 2 times negative 12, 2 and negative 12. Oops, negative 12. So that's great. So now we have two values. So all you're going to do now is, pretty simple. You're going to write 3x squared plus 2x minus 12x minus 8. Draw that squiggly line. And next, take your coefficients, 3 and 2. Greatest common factor is 1. Write nothing. Then we have x, or variables. The lowest number here is 1. So you're going to write x, and then it would be 3x plus 2. Kind of move that squiggly line here. And then we have negative. That's a common factor between these two, so you can write negative 1. And then here it would be, negative 2, actually. yeah, 4, sorry, guys. Negative 4 is our greatest common factor here. So then it would be 3x plus 2. Now that we have our same insides, we can bring one of them down. We know that we're doing this right. So 3x plus 2 times our outsides, x minus 4. So this would be our final answer. Now, going on into difference of two squares. So difference of two squares is basically when you have something like this, when you have perfect squares. So let's say we had 4x squared minus 12x plus 9. So our a and c values have to be perfect squares. So here we have perfect squares. So we can just bring that square root in. And all we have to do is the square root of 4 is 2. And then our variable is x. So we can just say x minus, and we're going to put whatever this value here is. So then you bring this down, the negative. Our b gives us our sign. And then square root of 9 is 3. And then you just put it square. Another example would be 25x squared plus 10x plus 1. This is a perfect square as well, and so is this. So 25, the square root of 25 is 5. Our variable is x. The sign is positive for b, so you're going to put a plus sign. Square root of 1 is 1. Put that in, put the parentheses, square it,